My last mini video of the day is going to be the reduction of alkynes, and this time I will do it just with the white pages, just the blank pages. So the reduction of the alkynes, it comes in several different flavors. And so you can have, for instance, an alkyne like this. Oops, pens. You can have an alkyne like this, and you can perform a reduction full power. Sorry about this. A reduction full power using hydrogen and palladium. And if I have excess of hydrogen, it is understood that all the time you have enough hydrogen to hydrogenate all what you can. Erase this. So then the result will be that you will add 2 equivalents of hydrogen, and you will end up with the corresponding alkane. So we have 1, 2, 3, 4, 5 carbon atoms. You end up with the corresponding alkane, the saturated alkane. So we added 2 moles of hydrogen, 2 equivalents. Another possibility is that you can use a catalyst that we call a Lindlar catalyst. So you also have hydrogen, but you use Lindlar catalyst. And that diminishes the activity of this catalyst. Sometimes they refer to that as being a poison catalyst. And so the catalyst is less effective. And the result is that you will get an alkene as a final product. 1, 2, 3, 4, 5 carbon atoms, and you will get an alkene. And then the third possibility is that you can perform the same reaction, the same starting material, but using lithium in ammonia. You can also use sodium in ammonia, and there are some examples in AL where they use sodium. Either one of the two metal works the same. So the result will be also that you will get, as a final product, you will get an alkene. So at this point you may say, hey, but what is the deal? We are getting the same product with hydrogen and Lindlar or with lithium in ammonia. So what is the big deal in having those two different methods? The big deal will come when we have an internal alkyne. So let's illustrate that in the next slide here. So here, how about if you have here an alkyne that is internal? If I use hydrogen and Lindlar catalyst, the result is that I will get the cis alkene. This is an alkyne with 1, 2, 3, 4, 5, 6 carbon atoms. So between carbon 2 and carbon 3, I will have my double bond, and I will have carbon number 1 there, and then carbons number 4, 5, and 6. So the stereochemistry of the product is cis, the cis alkene. If I was performing the same reaction, the same reduction, but using the same starting material, but instead using lithium in ammonia, in that case, I will get the trans product. So I will get the trans product. So once again, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So big difference, right? In one case, we get the cis product. In the other one, we get the trans product. So there we have three methods, right? Method number one, you can use hydrogen and palladium, and that will give you an alkane as a final product. If you use hydrogen and Lindlar catalyst, you get the cis alkene. And if you use lithium in ammonia or sodium in ammonia, you will get the trans alkene. Okay, so I will stop here and we will continue later.